Okay, 8.2, we start talking about trigonometric ratios, and trigonometric is a hard word for me to pronounce, and you know me, I'm lazy, so we're going to shorten that to trig ratios. So trig is the same word as trigonometric. And before we get started on what trig is, try this warm-up and make sure you you have the basic skills to be successful in this section. So try the warm-up. Pause the video. Here are the answers. Hopefully you got everything right. If you didn't, come to tutoring, please. So today, we are trying our objectives. By the end of the video, you should know how to find the sine, cosine, I don't know why I'm not highlighting these things, sorry, sine, cosine, and the tangent of an acute angle. That's super important. And then we're going to, at the end of the video, use trig ratios to find side lengths in right triangles and to solve real-world problems, because what would the point be if we can't use this and apply this in real life? So some basic vocab that you need to know is trigonometric ratio, trig ratio, sine, cosine, and tangent. What does it all mean? So we should know what those words mean by the end of this video. So if we're talking specifically about right triangles, only talking about right triangles right now, okay? And if we take two right triangles, let's say triangle XYZ and triangle DEF, if we compare these two triangles, well, they both have right angles, so that's one angle that's similar, and they both have 32 degrees angles, so these triangles are similar by angle-angle similarity. Same with this one. So in a right triangle, if you know that the other acute angle is congruent to another acute angle, then we know that those right triangles are going to be similar by angle-angle similarity. Okay, so that's really important. So these are all similar by angle-angle similarity because they all have two angles that are congruent to each other. And since they're congruent or similar, excuse me, that means that their sides have to be proportional. So for example, BC, this side, over this side has to be the same as EF over FD and has to be the same as XY over XZ. And since that's going to be true for all triangles that have, all right triangles that have a 32-degree angle, we call these trig ratios. So a trig ratio is a ratio of two sides of a right triangle. Okay, so again, if in all of the right triangles that exist in the world, if one angle is 32 degrees, then that means that the ratio of this, the shorter leg over the hypotenuse, will be the same for all right triangles with 32 angles. Pretty cool. So these trig ratios exist to help us figure out what that ratio should be, what that proportion should be for the side lengths. Now, a helpful thing that I use to remember what the difference between sine, cosine, and tangent are is something called SOHCAHTOA. I'll explain what that means in just a second. So again, trig ratios are ratios that compare side lengths in right triangles, because we just said if we know what the acute angle is in a right triangle, then it's going to be the same for all right triangles that have that same acute angle. A sine is one trig ratio that compares side lengths in a right triangle, and specifically it compares the leg opposite to the angle to the length of the hypotenuse. So for a sine, it compares the side opposite to the hypotenuse, which is where the SO comes from. So for example, if I wanted to know what the sine of angle A is, notice this angle right here, this letter right here tells me what angle I'm talking about, because there's three angles in a triangle. So if I'm looking at sine A, that's comparing the side opposite, which would be little a, to the hypotenuse, which is C. So that's how they get A over C. So it's just a ratio. If I wanted to talk about cosine talks about the length of the leg adjacent, which means touching that angle, as well as the hypotenuse. Now, the leg adjacent and the hypotenuse will never be the same. So cosine, it compares the adjacent one to the hypotenuse. And sometimes people write it like this. I've had students write it like that, which I think is smart as well. So cosine, if I wanted to talk about cosine of angle A, cosine of angle A, it's not the opposite side. It's got to be adjacent leg. So it's got to be B over the hypotenuse. And again, the hypotenuse and the adjacent leg are not the same. So cosine of angle A is going to be little b over little c. If I wanted to talk about angle B, because why are we neglecting B? Okay, so let's say I wanted to say cosine of angle B, figure out what that side length, proportion of the side length is going to be. Well, the side adjacent to angle B is got to be A, and the hypotenuse is still C, so that's how they get A over C for cosine of B. Again, it's a trig ratio. It's just a ratio that compares side lengths in right triangles. That's it. The last one is tangent, and tangent compares the leg opposite the angle to the leg adjacent to the angle. So no hypotenuse in this one, and that's T stands for opposite over adjacent. So you could write it like this, or you could write it like this. Okay, so if I wanted to know what the tangent of angle B is, it's comparing the side opposite, which is B, over adjacent, which is A. So that's how they got B over A for tan B. Again, a trig ratio is just a ratio that compares side lengths in right triangles. So sine, cosine, and tangent are just helping us figure out what those proportions are going to be in right triangles. Okay? So again, sine A, something like this, is just telling you to look in respect to angle A. Okay, so the first thing you're going to be doing is writing a trig ratio as a fraction and as a decimal rounded to the nearest hundredth for sine J. So again, this is important because it tells you which angle to look from. And you know, sine stands for opposite over hypotenuse. So the side opposite is 60 and the hypotenuse is 61. So this is your fraction answer. And then they also want you as want it as a decimal, rounded to the nearest hundredths. So that would be, I got 0.98, right? That's all you do. So that means in every single right triangle, with this particular angle measure, this will be the side, the proportion of those side lengths, the opposite one in the hypotenuse. Okay, same thing. So cosine J. Cosine J, we're still looking from angle J. Cosine stands for adjacent over hypotenuse. Sorry, adjacent over hypotenuse. So this is your fraction answer, and then you put it as a decimal, and I got about 0.18. All right, so try that for for the next one. Try that for tan K. Tan K, tan stands for opposite over adjacent. So the opposite one would be 11 because it's opposite. It can't be 61. We're not using the hypotenuse in this one. So then the adjacent one has to be 60. So this is your fraction answer. You know how to find the decimal rounded to the nearest hundredth. Okay, so try this one. Try to find cosine A. Try to find tan A. Try to find sine B. And we're going to check these in class tomorrow. Okay, so that's the first thing. Again, and ask yourself, write down what is a trig ratio again. We're going to discuss this answer in class. Okay, so the last thing we're going to do, the second thing we're going to do is compare trig ratios to special right triangles because we've been emphasizing special right triangles. And once you know what the trig ratio is in a special right triangle, guess what? It's always going to be that same answer. So this will really help us out in our advanced classes. So really quickly, use a special right triangle to write cosine of 30 degrees as a fraction. Again, this is just letting you know which angle to refer to. So we're looking at this one, and we know that cosine stands for adjacent over hypotenuse. So the side adjacent, is not opposite. So it would be s radical 3 over the hypotenuse, which is 2s. Now, all we have to do is simplify. There's an s on top and an s on bottom, so your answer is going to be radical 3 over 2. That means for every 30, 60, 90 triangle that exists in the world, if you compare the adjacent side to the leg, it will always, 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 always be radical 3 over 2. Pretty cool. All right, try to find tan 45 for this one, and again, we'll check it in class. I'm going to put a star so I remember that. Okay, Last thing we're going to do is we are going to use trig ratios to find lengths and, apply this to real world stuff, because that's really what we're looking for here. So it says find the length of BC round to the nearest hundredth. So we want to know, I'm going to put an X here. This is what we want to know. How long is this side? So now we know what the angle measure is, and we know what another side length is. And we have to think, first of all, which trig ratio are we going to use? Well, okay, if in respect to the 15 degrees, you could do it differently if you want to, but I'm going to show you how to use the 15 degrees. We have the side opposite, and we have the adjacent side. We don't have the hypotenuse. So the only trig function we can use is tan. So I'm going to write it as tan 15 degrees, tan of the angle, equals opposite over adjacent. So tan of the angle equals, I know opposite is 10.2, and I know the adjacent, I don't know what that is. And this is what we want to solve. Now I know this looks weird, but tan 15 is just a number. Tan 15 is a ratio comparing sides. So remember, this says that in every right triangle that has 15 degrees, the ratio of the sides is always going to be the same. And guess what? Your calculator knows what that ratio is. Pretty awesome. So this is a number. You're just going to solve for x. And to do that, I'll show you the long way. Multiply both sides by x. And now you get x times tan 15. Notice I put the x in front, equals 10.2. And then this is a number, so the opposite of multiplying is dividing, so divide both sides by tan 15, and you're going to get x equals 10.2 divided by tan 15. Now put this into your calculator. You need to have a scientific calculator. First semester you didn't need to. Second semester you need one. And I'll have a trig chart if you need one, but pop that into your calculator and that'll tell you what the answer is. Let me just make sure my mode's correct. Yeah, my mode's correct. So 10.2 divided by tan 15. My calculator says that that's 38 hundredths, 07 feet. That's what I got. If you got something differently, come before class and I need to help you with your calculator. Okay, so that's basically how you solve this one. If you notice, you don't really have to go through all these steps of multiplying and then dividing. Notice all you do when the x is on the bottom, this is just an algebra thing. All you do is flip-flop. Flip-flop the x and whatever's on the other side, x and whatever's on the other side, and that'll be what it is. If you don't understand the shortcut, that's fine. You can do the long way. Doesn't matter. Okay, I'll do one more with you, and then you're going to do one on your own because I'm running out of time here. Okay, let's see. Find the length of QR. So QR is x. I'll put x there. And look at what information you know. We know the angle is 63 degrees. We have the side opposite. And this looks like adjacent, but it's across from the 90 degrees. So we have opposite and we have hypotenuse. So we have to use sine in accordance to the 63 degrees. And we know that means opposite over hypotenuse. So sine 63 equals x over 12.9. And we want to get x by itself. So the opposite of dividing by 12.9 is multiplying by 12.9. So all you have to do is put 12.9 times sine 63 degrees into your calculator, because your calculator knows what sine 63 is. And I get that x equals 11.49 centimeters. If you don't get that, you need to come see me and get help on how to use your calculator. Okay, so here are some more examples. I'll give you this one to do. We'll check our work in class. And I will give you this one to do. Check our work in class. And then the one I want you to think about is, we're going to do this one when we get back. The Pilletsbahn in Switzerland is the world's steepest cog railway. Google it. Its steepest section makes an angle of about 25.6 degrees with the horizontal and rises about 0.9 kilometers. To the nearest hundredth of a kilometer, how long is this section of the railway track? We can use trig to solve this, and that's what we'll do in class tomorrow. Thank you. Remind yourself, what is a trig ratio and why do we use it? Why do we need to know it?